This next segment is a follow-up to the confidence intervals that we just calculated right here, assuming a mean of 6, a standard deviation of 2, and a sample size of 25. And we went through in the previous segment all the math that's necessary in order to calculate, in this case, 95% confidence intervals. And by the way, there's nothing magical about 95%. I pulled that one out of the air, mainly because that is the most common confidence interval calculation, 95%. But as you already know from the table, the t-table, I could have said, let's calculate 80%. Or let's calculate 99.9%, or let's calculate 98%, but I chose 95%. The purpose of this segment is simply to show what an appropriate drawing would look like in response to this request, calculating 95% confidence intervals. So here we go. If you don't already have this information, you might want to get it down. You can rewatch the YouTube clip and take notes, or you can just simply take a look at the confidence intervals, or the base information, mean of 6, sample size of 25, 95% confidence intervals, okay? We already found our t-value from the table. So, and we concluded our mathematical story by calculating the actual confidence intervals. So now I'm going to show how this information would get appropriately transferred onto a drawing. All right? And by the way, some of you really need to be sure that you're being very careful with your drawing. It's important to be as neat as possible. I realize I'm not the neatest drawer in the world, but I do try to be as clear as I can. Perhaps it will come as no surprise that we should start with the bell-shaped curve. This is the t probability distribution. And I'm going to start by creating the legend. Okay, the legend is n equals 25, which means degrees of freedom equals 24. Our task at hand is 95% confidence intervals, and our t-value that we pulled from the table is 2.064. Okay, so that's the same bell-shaped curve you just saw. All I did was add the legend in the upper left-hand corner of the drawing. N of 25, which means degrees of freedom of 24, n minus 1, 25 minus 1 is 24, 95% confidence intervals. I then consulted the t-table, which hopefully you're adequately familiar with at this point, and indicated the correct t-value. So the first thing I'm going to do is add some appropriate information to this drawing to indicate what we're doing here. What's the task at hand again? The task at hand is 95% confidence intervals. So that area in the middle is going to be 95%, which means, hopefully, if you hung with the YouTube clips that partitioned up the probability distribution before, you know that each of these tails is 2.5%. Also, one thing I haven't done before, I think I actually only did it one time, I like to add at least a dotted line down the middle, just demonstrating symmetry. Not a huge deal, but I do like it to be there. Now, the first thing I'm going to do is draw one line under the abscissa, and I'm going to put a t-value here. Hopefully you know which t-value that will be. It will be negative 2.064 because that came from the table. I'm going to put another t, or the other t-value here, t of 2.064, positive 2.064 here. And I'm also going to put a t-value in the middle. What t-value do you think I'm going to put in the middle? If you're thinking 0, you are right on the money, a t of 0. So that's what I'm going to add here. T equals negative 2.064 on the left. T equals positive 2.064 6.4 on the right, and t equals 0 in the middle. Now I'm going to draw another line underneath my first line under the abscissa, just like that. And I'm going to place some additional information. I'm going to place the mean right in the middle, a mean of 6. Mean of 6 right in the middle. Hopefully this exercise is looking somewhat similar to what you were doing before with the normal probability distribution. And then I'm simply going to take the information from what we were just working with, upper limit and lower limit, and place it in the appropriate spot on the drawing. The upper limit is 6.8256. If you rounded to 6.826, that's fine. I realize that we have been rounding to the 1,000th place within the context of this class. And I'm going to put the lower limit on the left, which is, as we already know from our math, 5.1744. That is a complete problem from beginning to end. We started with some assumed information right here, a mean of 6, standard deviation of 2, sample size of 25. We were asked to draw calculate 95% confidence intervals. We went through that trouble, and then we transferred that information appropriately to the appropriate drawing. All right, I will walk through yet another example with you.